Alright, let's do question 11 to 14. In this question, you're given the electrochemical cell as written, and of course, our memory aid is ABC, right? Anode, bridge, cathode. Therefore, to answer question 11, what is the anode and the cathode and their respective polarities? So let's answer the question first, the anode and the cathode. Whether you have galvanic cell or electrolytic cell, the anode is always positioned on the left. So your lead is the anode, right? And your platinum is the cathode. So Pb is the anode and platinum is the cathode. It's always like that, whether you have galvanic or electrolytic. Now, as to the polarity of the anode and the cathode, it depends. If you have a galvanic cell, that means the potential is positive. The anode is the negative electrode and the cathode is the positive electrode. And it's the opposite when you have an electrolytic cell. So how do you find out whether you have an electrolytic or a galvanic cell? Given the potential, so these are the potential from the reduction potential table. So you have 0.36 and 0.56. So if you calculate the potential based on the arrangement here, so you have E manganese minus E lead, right? E right minus E left. So if the manganese is 0.56, so the way it is written, the potential is 0 E cell is 0.56 minus 0.36, right? And that is actually positive 0.92. So that means this is a galvanic cell. And if this is a galvanic cell, then the anode is the negative electrode and the cathode is the positive electrode. So anode is negative, cathode is positive. Okay. Now for question 12, we have already calculated this. What is the standard cell potential E naught? So E naught cell equals E naught right minus E naught left. So your right is the manganese, which is 0.56, 0.56 minus 0.36, 0.92 volt. Okay, so that's your E naught. Now, what is the actual cell potential? This is a little bit complicated because we have to find the overall reaction. So to write the overall reaction, we can get the clue from the way it is written in the cell notation. So what happens at the anode is always oxidation, right? So therefore, lead is oxidized and manganese is reduced on the other side. So the oxidation half reaction would be oxidation of lead, which is just the reverse of this reaction as written. So we have Pb plus SO4 2 minus PbSO4 plus 2E. And the reduction, half reaction, would be the reduction of MnO4 minus plus E yields MnO4 2 minus. Now to get the overall reaction, we need to balance the electrons, so you can cancel them. So we have to multiply everything by 2 here, so the E cancels. And so the cell reaction, the overall cell reaction would be Pb plus 2 MnO4 minus plus SO4 2 minus yields PbSO4 plus 2 MnO4 2 minus. So this is the overall balanced equation. And we can calculate the actual cell potential using the overall cell potential, which is 0.92. So E equals E naught minus 0.0592 over 2, because there are 2 electrons involved in the reaction, and then log of. Okay, we have to find the Q expression based on the overall reaction, because the E naught that we are using is the overall E naught. So this is concentration of MnO4 2 minus square, because of the 2 there, divided by MnO4 minus square. Again, you have 2 there, and SO4 2 minus. So substituting, we have E equals 0.92 minus 0.0592 over 2 log of the actual concentration of MnO4 2 minus is 0.029, 0.29 square divided by MnO4 minus is 0.13 square, and SO4 is 0.12. If you evaluate this, you get an E value of 0.87 volts. So that is the answer for question 13. So that's the actual cell potential. This is the E naught, and that is the actual cell potential. Now, question 14, what is the equilibrium constant? So we actually derive already the calculation or the formula for KEQ, which is antilog or 10 to the N E naught over 0.0592. So this is 10 to the 2 because 2 electrons are involved, and then E naught is 0.92 and 0.0592, and this is equal to 1.21 by 10 to the 31. That is KEQ, and that is the answer for question 14.